Welcome to Programming with Qt Widgets. In this episode, I will look at ranges. I'll look at the C++ ranges, and more specifically, I'll look at the missing bit, namely the possibility to write pipe sort. Okay, what am I talking about? I'm talking about C++ ranges, the new thing in C++20 where you could pipe things through a number of algorithms. You could take a collection, pipe it through a filter, pipe it through transform, pipe it through sort. Ooh, no, you couldn't pipe it through sort, which was, at least in my code, the use case that I had a lot of times, but that was not possible. I was complaining to a coworker the other day, and he did the thing that I hate when they do to me. He said, "How hard can it be?" I said, sure, if that's a challenge, I'll take it. In this episode, which will be a fairly long one, I will show you my implementation, but I'll walk you through the realization that made up to that implementation. At the end of it, we will have talked about lots of interesting stuff like template, no, I wasn't repeating myself, template parameters, and lots of other stuff. Argument dependent lookup is one of those. So stay tuned. Okay, let's look at some code. It starts out pretty simple. I have a for loop here. In my for loop, I have a number of people that I pipe through a filter. I filter those that are older than 27. I transform that I take the name of the person and I print out that name. It rolls off the tongue, and that's the beauty of these ranges in ranges v3 as it was originally, and now in C++ 20 and above, namely stud ranges and stud views. There is a number of things that I did in here to make it roll more easily off our tongue. So let's just look at that. So I have this shared, which we will be using. As you can see over here, I have 7 parts. I'll be using that in a number of those parts. So let's just go and look at what shared gives us. It gives us a copyright header. Okay, namespace views, so namespace views equal to stud views. That's just to make it easier to say views, : and views, : instead of stud, : views, : filter. Easy peasy. It's a, I think it came in C++ 17. It's a pretty cool thing that you can do these things. Okay, then I have a print function, and the print function, it takes a string. So there's no print down here. We'll see that in a bit. The print function takes a string, so it prints out the title here. It takes a ranges as a ref, so that is a forwarding reference, I believe it's called, universal reference if you ask other people. Anyway, ranges ref. And why is that not a const ranges reference? Ooh, for that, you'll have to watch a very long presentation from Nicola Yosutis, where he's talking about especially some of the shortcomings in ranges. Anyway, I print out here, so that's just a utility function for printing out. I have a person, easy peasy, that's just a struct with 2 things in here. I have an overload of operator less than, so I can print out persons. You see cout, blah, blah. So I can actually print out my persons that way. I have a vector of people, vector of persons, namely people, Adam, Alice, Diana, Charlie, Bob, and Andrew, and their associated ages here. And if you're wondering, is that a reference to Depeche Mode or something? Because I've had those in the past. No, it's not. That's a GitHub Copilot that came up with those names for me. Anyway, here is the last part, and I love that really very much. Older than is a lambda expression that returns a lambda expression. So older than takes the age, and it returns the lambda expression that takes a person and returns whether that person is older than the given age. Couldn't that just have been a older than 28? Yes, it could. And then I would have another one older than 29 and older than 40. I don't know if I would have all of these, but it reads so much better or rolls so much better off the tongue when I can just say older than 27 here. So now we have my people. I've pipe that through views, stud views. filter older than, so this is a lambda expression that returns true if a person is older than 27. I pipe that through views, std views, transform, which takes a pointer to an instance variable here, namely name. So we have name up here. And what I get out of that is, if I run it, I get these names printed out. Easy peasy, very beautiful, but I cannot pipe through sort. And that was where a coworker came and said, why don't you just implement that yourself? It's not that difficult. I was like, okay, maybe not for you, but I have no idea where to start. And the answer was as mind-boggling as it was simple. Just overload operator pipe, global version of that, to take something, so auto, and to take an instance of a class called sort. Let me show you the code. You'll be surprised how easy that is. So let's look at the outcome here. Pipe, auto, name, people, filter, transform, and sort. So I just pipe through sort here. And if I run it, I can see I got my people now printed out alphabetically. And what does it look like? Well, I implement the operator pipe, that's this little fellow here, to take whatever came before it in the list, so whatever view I had already, and sort. And I don't even need that for anything, I just need it to be sitting there. So sort here, and this function here will be called at the time when I have this operator sort here, and all of whatever this is generated is going to be in view. It's going to be something that I can iterate with begin end, and it has the second parameter being whatever I gave it here, but I don't even use that. I just need it as a token there. So std vector, I'll create a vector of my view. So I'll just take my view, begin end, whatever that view was, I now have that as a vector. I use std ranges sort on that, and I return my vector, and ta-da! That's it. I hope you enjoyed it. What? More seconds on the video? Oh yeah, I'm not done yet. What am I missing? Well, how about if I want to sort decrementing rather than ascending? Descending rather than ascending. Yeah, well, std ranges sort actually has an answer to that. So if I go over to std ranges sort in the reference documentation, you can see this is the one with the iterator, which I'm not interested in. This is the one template, blah, blah, blah. This is the one taking a range, and it takes a comparison. So that's a binary expression that tells whether one object is whether one object is less than another object, or it takes a projection. So that is, say, the ampersand names to go and fetch just that one out and then compare that. I can definitely do that too. Let me show you. Let's start looking at the code of how it will work then. So I have my print this time now. It takes the description here, sort by age and name, people, pipe filter, pipe sort by age and name. So sort is now a method that takes this parameter. People, pipe filter, and pipe sort, and I can even continue my piping on. So pipe transform names. It still works without any parameters, and it works by specifying the empty element here as the first one, and then doing the projection on the second one. And let's just run it here. You can see sort by age and name, 30, 35, 40, 40, 100, and Andrew is before Diana. So that seems to be working out fine. Sort plus transform. So that is taking the name afterwards. So L is Charlie, Andrew, Diana, Adam. So that worked too, it seems. And you have to trust me that the other works. Or you can look at it. Just pause me here, and you would be able to see those. Okay, let's see how that is implemented now. So by age and name, that's just a lambda expression taking two persons and comparing first the age and then the name. And If this is the first time you see this, please do observe how you compare multiple elements here. If they are different, then return that. Otherwise, if the second one you want to compare is different, then return the less than, and so on. Okay, let's see what the sort looks like now. So my sort, as you can see, it takes a parameter here. So my sort up here, it takes the compare and the projection, and it is a template now. Template type name compare. So the default is less, the projection, the default is identity. And how did I come up with that? I looked into what std_range's sort took of parameter, obviously. And it takes a compare that is defaulted and a projection that is defaulted. So that is how I still can write sort parenthesis open parenthesis close. It just remembers those. So shouldn't it sort by those? Well, it just remembers them, because remember my operator parenthesis, that's the one that did the real sorting here. Before it just took the sort as a token, but now it actually takes the sort here and it runs the vector, or it creates the vector again here. It sort and gives these two parameters. And just like when I look at it, maybe I should have given it sort const blah 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 reference sort. Let that be. I will show you a complete solution in just a few minutes. So that's it. Now we're almost done. And this was not the first solution that I came up with, because as soon as somebody said, why don't you do it yourself? I thought, well, let me look at what does a simple view do. So I looked at std_view's iota, which is a relatively simple view, and it was doing it rather different. So I did it rather different myself. And then I started cutting that down into a simple example, step by step, as you've seen by now. And I came to this and I was like, why did iota do it this really complex way? So I reached out to my default go-to C++ expert in KDAP, namely Giuseppe D'Angelo. Thank you, Giuseppe. And asked him, why are they doing that? And I'd like to show you why iota is doing that. But for that, we need to do a small detour. Okay, let's imagine that we have an algorithm library that is called myalgorithms. And myalgorithms have a sort in it. And this sort is the iterator version one that takes a standard random access iterator and stud since Nintel 4, blah, blah, blah. That is what C++ 20 and up looks like these days. It does this by simply calling whatever and then calling the regular one. Why would I want that? I might have a special way of sorting, so I wouldn't just call onto the regular one, but this is just to show you what is going on here. I have a vector. I call my algorithm sort, vec begin, vec end, and I print it out. Are you ready? Can I get some drums? Excellent. What do you think it will print out? Called my sort algorithm, and they are sorted. Amazing, isn't it? Well, it's not that simple. Okay, I will make a small adjustment. See, part 4, part 5, part 4, part 5. Did you see the difference? Well, the difference is this. I even highlighted it for you to make it extra using namespace my algorithms. So I don't want to write my algorithms : all over the place, so I just write my algorithms. And the code is exactly the same as you also saw, except that it doesn't say my algorithms : sort. So I'll run my code, and it print out that the numbers are sorted, but it didn't print out called my algorithm. So why did it not call my algorithms? How much time do you have? I'll give you the short version, ADL. Oh, you want the longer version? Argument dependent lookup. The argument dependent lookup is this tricky thing that makes it possible for it to realize that one of the argument is a vector. So it will look up in stud vector whether there is a version of sort that it can use. And stud vector in stud, not in stud vector, but in stud, there is indeed sort. And that one takes two parameters. a iterator and an iterator. Mine took an iterator and stood sentimental for that iterator. So iterator was actually closer than my version, and therefore it chose that version rather than my version. That is a nightmare that I cannot use namespace my algorithm up here. And the solution that somebody clever enough came up with is exactly what I'll show you in step number 6. So the trick is to not use a method or a function in this case here, but instead have a class with an operator or the call operator, operator parenthesis open parenthesis close, implemented. So my code still says sort blah blah, but what sort really is here is now an instance of a class called sortable. And that class has this operator parenthesis open parenthesis close, taking these parameters and doing its work. And if I run it now, you can see it was again mine that was called, despite that I had my using namespace my algorithm, because that one won big time over the overloaded functions, namely this implemented class here. And this gets me to the final version of my sort view. This time I'll do that same trick of implementing a class that has the call operator implemented on it. Before I show you the code, let me just show you how it looks like when I use it. It looks pretty similar to what I did before. It's in a namespace now, Qt Widgets and more, : sort, but that's the only difference to the standard version here. It has the ability to do these different types of parameters and also the default one here. And it has a ability, if I can find it, where is it on my screen, to say sorted to, because the sort here spits out a std vector, but I might actually need it in, if I'm a Qt developer, in a Q list that I can give to something else. So I can specify a container type here, not a Q list of integers, but a Q list of, just a Q list, whatever it's a Q list of, it will figure out by looking at the parameters. That's pretty cool. Also, when I have my input, people, pipe, something, whatever I have that I wanted to spit into needs to be something that I can actually sort on. So it needs to be a container. And if I just compile this here, well, I cannot even compile it. Oops, I cannot even compile it because it will tell me, hey, there is a problem, static assertion, that this destination type isn't random access. So I spit it into something and then I call sort on it, but obviously I can't do that if what I spit it into is a forward list, because you can't sort a forward list. It needs to be random access. That is a feature that I built in to my sort view. So let's have a look at what does that look like. If you're not interested in details, thank you very much for watching this. Just copy sort view out of the code here and you are good to go by piping through sort. But for the rest of you, well, stay tuned. I will explain the code. It's pretty cool if you ask me. Oh, you stayed around. That's very kind of you. Let's dive into the code now and try and understand as much as we can from it. Let's take it bit by bit. We start out with my method up here, the operator pipe. So that's the one we saw before. It takes the input, that's what I called views earlier on, and it takes this detailed sort view, compare blah blah view. So it takes my new view here as a parameter. What I want to do is that I want to take this input that I have here and I want to sort it. And as of this recording, it's now 2025, almost to 2026. So you might say, Jesper, aren't you a bit late to the game looking into ranges by now? And I'm not entirely late to the game. I did look into it in 20, but back then we did not have this std ranges 2. So either I would have had to implement that myself back then, and I was not that good at templates back then, or I would have had to write 2 lines of code to get my data out of my pipes. And if I have a for loop, I could just iterate as we saw before. But if I have something where I would like to take it and give it to a QList view, for example, then I would have to go through a number of steps to get the data out, which was, to say the least, slightly annoying. Okay. In C++23, we now have stud ranges 2 taking a container type. So that could be stud vector, for example, or QList. And then it simply creates a copy. My type of my QList is result container of the values in my input. Okay. If I do not have, then all of this applies. I'll get back to that in a second. Okay, so my operator pipe takes the input. It takes whatever I have there. That's my sort view that I'll be showing you in a bit. And it takes the input container, spits it into copy. And now what I'll do then is just call stud ranges copy, stud ranges sort on my copy with the parameters that was given here, and return that copy. That's just as before. There's one more bit here. There is a static assert. That's also a C++20 feature. Static assert claims that the decal type of my copy, so the type of this copy up here, needs to be of the type stud ranges random access range, or it needs to fulfill that requirement. And if not, then it will spit this out. That's just beautiful C++20 code, because rather than I get an error deep down in the stomach of sort that it couldn't do whatever with the parameters, it now tells me, well, the destination type isn't random access. Okay, that was my operator pipe. But what did the operator pipe take? Well, as before, my operator pipe took something like Qt Widgets and more sort. So let's look at what is Qt Widgets and more sort. Well, that is, scrolling up here, is a class now. The class is an instance of, or it's a specialization or whatever you call that, of detail sort with the type stud vector as the template parameters to it. I also have a sorted too, as we saw before, and that one is a template. No, I did not repeat myself. Template type name. So what this one says that it's a template, and it takes one parameter here, which is a container. So stud vector, QList, not a stud vector of int or QList of strings, but just a stud vector or QList. It takes a container, which is defaulted to stud vector, by the way, and it will then, well, create this object called sorted2. Sort and sorted2. Let's go up and look at what they look like. So sort and sorted2 are instances of detail sort. That's the class we have here. It's a template class of this container. We saw that right down there. And it implements an operator, parenthesis, open parenthesis, close. That's a call operator. So on that object, sort, I can specify 2 parameters, both being defaulted to be nothing here. And what does all of this say? Well, it says that the parameters of them is compare, defaulted to studless, project, or projection should have said defaulted to identity, and that are the 2 parameters that I'm giving here. So my sort view takes my compare, my project, and the result container, and that is the return type. I don't know. Why did I not just write auto? Because I had this one over here still comes in. Now with auto, and it compiles. So I could have written auto. Who knows? What I return is a sort view. So this class sort itself in its call operator returns another class, namely sort view, which forwards the compare and the project. And the sort view is the one that remembers the 2 parameters, and those 2 parameters are used in my scrolling down here, they are used in my sortview.comp view.projects. I don't know if there's even anybody watching this anymore, but that's cool. I have one tidbit more in here, namely, what if I do not have a C++23 compiler? If I have a C++20, obviously I wouldn't have a C++17 because this is a feature of C++20. But what if I only have a C++20 compiler? Well, in that case, I can just take my stuff here and take my input and push it into a new, or into this container. So I just copy this result type here and push back. That was my initial reaction. And again, Giuseppe said, well, that seems rather expensive because we do have other alternatives. And this is just to give you an idea of what can C++ look like these days. So first of all, my result type, that is the type of the actual. So std vector of int or std vector of strings or whatever. That is my result container with std ranges values type t input. So it takes the input type up here. What are the individual elements in that? Okay, they are int or string or whatever. So result type is now that type. I create a copy of that. And then I just push back, and Pepe said, no, Pepe, that's Giuseppe. He said, no, that seems expensive. How about if we just call begin and end? Create it like this. That's more optimal code. And I said, there is no such thing as more optimal. Optimal is, okay, never mind. I said, okay, let me do that. I said, no, but it might not have begin and end. Like, Pepe, can you make up your mind? And he said, well, we can validate if constexpr. So that is at compile time. If the input has the capability of being a common range, that's something that has a begin and end associated to it, then I'll use that. If it doesn't, it could be something that did not have that. Then I can check whether, or then I'll just do the iterate through with my for loop. But okay, let me do that. And he said again, but you want to call reserve. Let me insert reserve. But it might not have reserve. And that's what I'm testing here. If constexpr, and let me not go into that, but if it does have reserve, then call reserve first on the input and then call the pushback. Why do you need to know that? You don't need to know that for your use of this class. All you need to do is to go to the link below and fetch this code here, copy it into your code base, and be happy ever after. Now you at least know that we have been putting in some thoughts into making it somewhat working pretty nicely. And you need to know this if you want to write some code like this yourself, which is, at the end of the day, more contemporary C++ than what it might otherwise have been. For those of you that are still around, it's really weird time to say this. If you are on C++17 or even C++14, do not despair. You can still use this facility here. Back then, or what came in C++20 was from something called ranges v3. There is a link below me telling you about ranges v3. And you can still use that in your code base to get ready for C++20 or just use this regularly. Argument dependent lookup. There was already a link below for that. I did a long interview with Nikolai Yosutis on ranges, among other things. There is a link below to that interview in case you haven't seen it yet. And finally, template parameters. That's a cool thing. There is a link to that too. And now there are no more links. So thank you very much for watching this episode and welcome to the future.